We're all part of these secret clubs we didn't even know we joined. Seriously, we're all surrounded by these invisible social networks, our families, our friends, the people we work with, and today we're going to explore the hidden architecture that really shapes our world.
But here's the big question, right? We've all seen groups fall apart. Friendships just kind of drift. Teams at work splinter. But what if those fractures aren't random at all? What if there are fault lines you could actually see, mathematically, way before the earthquake ever hits? Well, that's the puzzle we are going to solve today.
To get our heads around this, we have to travel back in time to the 1970s, to a university karate club. Now, this isn't just any old club. It's probably one of the most famous social networks ever studied. What happened was, a big dispute broke out between the instructor, that's person number 1 on the chart, and the club's administrator, person 34. And the whole club just split right down the middle. Okay, but here is the absolute bombshell. For one sociologist, Wayne Zachary, this split was no surprise at all. He had been meticulously mapping out who was friends with whom outside of class. And because of that, he saw the fracture lines forming and predicted almost perfectly who would side with the instructor and who would follow the administrator. He only got one person wrong. Insane, right? So that's the million-dollar question, isn't it? How on earth did he pull that off? I mean, it sounds like some kind of social magic, but it's actually a really powerful analytical method. So let's pull back the curtain and find out what the secret is. The whole secret lies in this idea called community detection. And to see the fault lines in any group, you first have to understand what a community actually is, at least in the world of network science. The expert, M.E.J. Newman, puts it perfectly here. It's really all about finding the natural clusters. Think of it like this. A community is a group where everybody is really tightly connected to each other, but only kind of loosely connected to the outside world. Yeah, to put it even more simply, it's just about spotting the different cliques or squads or friend circles that naturally pop up inside any big group. Doesn't matter if it's a company, a school, or, yep, a karate club. So, how do we actually find these squads? Well, network scientists and the algorithms they build, they kind of act like detectives. And they're looking for two very specific clues in the way the network is built: how dense a group is and what bridges are connecting them. So clue number 1 is density. And this is just a fancy way of measuring how interconnected a group is. Are there connections between almost everyone, or are the links pretty few and far between? It's basically the ratio of actual friendships to all the possible friendships that could exist. So, for example, a high-density group is like that tight-knit circle of best friends you had in high school. Everybody knows everybody. A low-density group, that's more like the people in a giant university lecture. You might know a few of them, but the connections are pretty sparse. Communities, the things we're looking for, have super high internal density. All right, the second clue is even cooler. It's called edge-betweenness. See, not all connections are created equal. Some friendships are just casual links, but others are critical bridges that hold completely different parts of the network together. And if you remove that bridge, the whole thing could fall apart. So how do you actually find these bridges? It's actually pretty intuitive when you think about it. Imagine information is trying to flow through the network. The quickest way to get from any one person to any other is the shortest path. Well, a connection, or an edge, gets a high betweenness score if it happens to lie on a ton of these shortest paths. It's basically the superhighway of the network, connecting groups that would otherwise be really far apart. Okay, so we've got our clues. We're on the hunt for dense clusters that are connected by these weak bridges. Now let's look at how the algorithms actually use these clues to go out and find the hidden communities. So there are basically two ways to go about it. The first is what we call bottom-up, or agglomerative. It's kind of like a matchmaker, starting with single individuals and pairing them up, then pairing those pairs up and building bigger and bigger groups. The second way is top-down, or divisive. This is more like a demolition expert who looks at the whole city and strategically removes the most important bridges to reveal the separate neighborhoods underneath. Let's look at the matchmaker first. The process is pretty straightforward. You start with every single person as their own little island. Then, the algorithm finds the two closest islands and builds a bridge, merging them into one. And it just keeps doing that over and over, merging the next closest groups until everyone is part of one giant supercontinent. Now, for the demolition expert. This method is the complete opposite. It starts with everybody in one big group. Then, it calculates that betweenness score for every single link, finds the most critical bridge, the one holding different parts together,
and it just cuts it. It repeats this process, snipping the next most important bridge again and again until the network has broken down into its natural separate communities. This is how Zachary saw the split in the karate club.
Now, for both of these methods, there's a guiding principle. The algorithm is always trying to find a division that maximizes a score called modularity. And in simple terms, modularity is just a measure of how good the community structure is. A high score means you've found a split with really dense connections inside the communities and really sparse connections between them. That's the sweet spot.
So this whole thing might have started with a little karate club, but the applications today are absolutely staggering. This ability to see hidden groups has jumped right out of sociology papers and into pretty much every aspect of our modern lives. I mean, scientists use this to find clusters of genes that work together, which helps us understand diseases. Public health officials use it to find super spreaders during a pandemic. Marketers use it to discover influencer groups. And political scientists use it to map polarization online, literally watching in real time as different communities drift apart. It's everywhere.
Ultimately, what community detection does is give us a pair of X-ray glasses for society. It makes all these invisible structures, the friend groups, the political tribes, all of it, suddenly visible and understandable. It reveals the wiring diagram of our world. And that, of course, leaves us with a pretty profound final thought. We now have the tools to see the fault lines in our social fabric before they break, to identify the key players, and to track how ideas spread. The question isn't, can we see these hidden structures anymore? The question is, now that we can, what are we going to do with that knowledge?